Hi dear students, welcome to Mandawad Maths Academy. Now today we are going to start the new chapter, the complex number. From today onwards we continue these videos of the complex numbers. So if you are new to this channel, please subscribe the channel and forward it to your friends this video. Now let us start the complex number. What is complex number? How it work and why we require the complex number to learn the complex number. So this is very important topic, and this is the complex number is the superset of all set of numbers, and which is defined as z is equals to a plus ib. So why we require the complex number? If we have real numbers, why we require complex number? So let us consider. I start from the one example. Let x minus 1 equal to 0. So this is a linear equation. Am I right? So what is the solution of this equation? We know, substitute here x equal to 1, we get the 0, means x equal to 1 is the solution of this linear equation. Am I right? Yes. Now second example, let us consider x square minus 4 equal to 0. So this is a quadratic equation. So what is the solution of this quadratic equation? So this can be written as x square equal to 4. Am I right? So we take square root on both sides, we get x equal to plus minus root 4, means x equal to plus minus 2, means there are two roots, x equal to 2 and x equal to minus 2. So these are the roots are complex, are real numbers here. Now x square plus 1 equal to 0. So what is the solution here? So here x square equal to minus 1 means x equal to plus minus root minus 1. There is no root minus 1 in the complex, in the real numbers. Set of real numbers, there is no number like this. So this number is called as imaginary number. What? So this number is called as imaginary number. So that is denoted by I. What is that? I. So therefore x equal to plus minus I is the root of this given equation. So therefore we required the complex number. I required. So there is no number like this in the real number. So therefore we can define a complex number. So that is in the form of a plus ib. This I is nothing but imaginary part of this complex number, and a comma b are the real numbers. So therefore you can remember this root minus 1 is the I. Is it okay? Why we required complex number? So the solution of this equation is not defined in the real numbers, means that is solution of this equation is x equal to plus minus I. I is nothing but root minus 1, that is not belongs to in the real numbers. So therefore we define the new set of numbers. So that set of numbers is the complex number, and that is denoted by z. Complex number is denoted by z, and that can be written in the order pair a comma b. A and b are the real numbers, and this also written as z is equals to a plus ib. So this a is called as real part. What? Real part. And b is called as imaginary part. So this is imaginary part. So you can remember in this root minus 1 value is I. So this I is called as imaginary part or the imaginary number. Is it okay? So we know that we have studied in the 10th class. So what is the value of delta? Delta is nothing but b square minus 4ac. Am I right? We have studied in the quadratic equation. Delta is equals to b square minus 4ac. This is called as discriminant. What? Discriminant. We know that what is solution formula method? X equal to minus b plus minus under root b square minus 4ac divided by 2a. So whenever we get in this root negative number, means delta value which is less than 0, then this number is called as, so that becomes complex number. What? Complex numbers, means that is not real. Complex number is nothing but that is not real. When delta value is which is less than 0, means that required negative number in the under root, means there is does not exist that number in the real number. Therefore this number is called as complex number. So therefore we require the complex number. Is it okay? The first chapter, so that is complex number. complex numbers. So this is, so we know already what are the numbers and what are the types of numbers. So I shortly I recall the numbers. So this n, what is capital N? Capital N is nothing but the set of natural numbers. So in the set of natural numbers which are start from 1, 2, 3 and so on. So these numbers are called as natural numbers. So natural numbers are generally used to count any objects. Then we want 0 here. So therefore, so this W is indicates the set of whole numbers and which added 0 in this 0, 1, 2, 3 and so on. So these are numbers are called as whole numbers. Then we want negative numbers also. Then this is denoted by I. I is called integer, set of integers. Which are negative numbers? Negative numbers 0 and positive numbers. So this is integers, set of integers. So set of natural numbers is the subset of set of whole numbers, and set of whole numbers are the subset of set of natural numbers, which is subset of set of whole numbers, and set of whole numbers which are subset of set of integers. Similarly, set of natural numbers is also subset of set of integers. So by using these integers to form real numbers. So real numbers are generally denoted by R. Or first you can write rational numbers, rational numbers, rational numbers, and irrational numbers. Irrational numbers. So rational numbers are generally denoted by Q. What? Rational numbers generally denoted by Q, and irrational number which are denoted by Q complement. So this is a rational numbers and this is irrational numbers. So rational numbers are denoted by, so that can be written in the form of P by Q. This Q is not equal to 0 and this P comma Q which are belongs to integers. So this is the definition of rational numbers. For example, 2 by 3, 1 by 2, like that. These are the rational numbers. So what are the irrational numbers? So irrational numbers, so that are non-terminating and non-repeating rational numbers, decimal numbers. For example, irrational numbers are root 2, root 3, pi. So these are the irrational numbers. Now the real numbers. Real numbers. So real numbers are generally denoted by capital R. Real numbers denoted by capital R, and which is the set of rational numbers union irrational numbers. The real numbers are the union of rational numbers and irrational numbers. So that are called as real numbers. Once again I repeating this natural number is the subset of whole numbers are subset of integers, and integers which are subset of rational numbers, so which are all subset of real numbers. Irrational number is a subset of real number, rational number is a subset of real number, and rational number is a complement set of irrational number. Irrational number is a complement set of rational number. Means irrational number and rational number are disjoint sets. Means there is no common elements in rational numbers and irrational numbers. So these are the introduction of types of numbers. Now we are going to start the complex number. So why we required the complex number? Complex number is generally denoted by Z. What? The complex number is denoted by Z, and which is written in the form of A plus IB. What? Complex number that can be written in the form of A plus IB. Complex number which is written as A plus IB. What is A and B? A and B which are belongs to R. What is R? R is the set of real numbers. So then Z is equals to A plus IB, where this A comma B which are belongs to R. What is R? R is set of real numbers. Now another definition, complex number is an order pair of elements, real numbers. complex number is an order pair. You can write like this, order pair. This is called as order pair of real numbers. Means A and B are real numbers. A is called as first component and B is called as second component. This Z can be written as again like this, A comma B, in the form of order pair. This A comma B which are belongs to real numbers, and this can be written as R cross R. Means Z is complex number is an order pair of real numbers, which can be written as Z is equals to A plus IB or Z is equals to R cross R. Means first and second element which both are in belongs to R means set of real numbers, or the set of complex number is denoted by capital C. What is capital C? Set of complex numbers. Set of complex numbers. So that is defined as, you can write like this. This is order pair A comma B, and which is belongs to A belongs to R and B belongs to R. So this can be written as R cross R. So again, once again I repeating this. This complex number is the superset of this all set of numbers. Complex number is the superset of N, W, I, Q and Q complement in this R. So N is a subset of W, so therefore N is a subset of integer. N is a subset of Q, means rational numbers. N is a subset of real numbers. N is a subset of complex numbers. N is the smallest set among this, and the complex number, set of complex number is denoted by capital C. Capital C is the superset of this all set of numbers. Okay. So we start the operations on the complex numbers. Okay. We can start the next operations, or we can write fundamental operations of complex numbers. Complex numbers. So complex numbers means Z1 and Z2. We denote the two complex numbers. One is Z1, another is Z2. That can be written in the form of A plus IB, where A and B are the complex numbers. Or you can write Z is equals to A plus IB in terms of order pair. So let first one, addition of complex number. Addition of complex number. So how to add two complex numbers? Let us consider Z1 and Z2 are two complex number. Z1 is equals to A comma B and Z2 is equals to C comma D. Let us consider these two complex numbers. So how let us consider there are two complex numbers Z1 and Z2. Z1 be the A comma B and Z2 be the C comma D. So Z1 plus Z2, that can be defined as first component plus first component, means A plus C, and second component plus second component means B plus D. So this is the addition of complex number. Next is subtraction of complex number or the difference of complex number. You can write difference of complex numbers. So again you can remember same thing you can do here. Z1 minus Z2 is equals to A minus C comma B minus D. So this is first corresponding component you can subtract from the first to the second or the second to the first. Z1 minus Z2 is defined as first component minus second component, first second component minus second component, first second Z1 minus Z2. Next one, third one, negative of a complex number. Negative of a complex number means, suppose let us consider Z1 is the or Z is the A comma B, then the negative of complex number is denoted by minus Z, and Z is a complex number, negative of Z is minus Z. So that is minus a comma minus b. So this is a negative of a complex number. Next one, fourth one, equality of two complex number. Equality of two complex numbers. Complex numbers. So let's consider Z1 and Z2 are the two complex numbers, and Z1 is the A, B, Z2 is the C, comma D. When we say Z1 is equals to Z2, if A is equals to B and C equal to D, means first component equal to first component, second component equal to second component, then we can call it as that two complex numbers. Then Z1 is equals to Z2, means these two complex numbers are equal. So once again I repeating this, addition Z1 Z2, Z1 plus Z2 is the A plus C and B plus D, means first component plus first component, second component plus second component. So difference of a complex numbers means Z1 minus Z2 is equals to A minus C and B minus D. Negative of a complex number, let us consider complex number Z is equals to A comma B, then minus Z is minus A comma minus B. Equality of two complex numbers, if A equal to B and C equal to D, then Z1 is equals to Z2, or vice versa. Z1 is equals to Z2, that implies that A equal to B and C equal to D. So these are the operations of complex numbers. So next multiplication of complex number. Let us consider if Z1 is equals to A comma B and Z2 is equals to C comma D, then Z1 into Z2 is equals to, so here we take the real part AC minus this imaginary BD. You can write like this, AC minus BD, comma, this is first component, AC minus BD, and you can write second one, A into D, AD plus B into C, BC. You can write like this, real, imaginary, real. Here you can write plus. So this is the Z1 into Z2. The product of two complex number, Z1 into Z2 is A into C minus B into D, or comma, imaginary part is A into D, real part, imaginary part, plus imaginary part, real. Let us consider Z1 is equals to A plus IB and Z2 is equals to C plus ID. Let's prove Z1 into Z2 equal to this one. So Z1 into Z2, that can be written as A plus IB into C plus ID. So you can remember here, I square is equals to minus 1, I equal to root minus 1. So substitute in that, the first component is the first component, A into C, then plus A into ID, means IAD, plus IB into C, IBC, IB into ID, plus I square BD. So AC plus II outside, here AD plus BC, here I square is minus 1, no need to write, you can write direct BD. So this is a real part and this is also real part, means there is an no I, you can write AC minus BD plus I into AD plus BC. So what is this? This is a real part and this is imaginary part. So therefore, you can first component is AC minus BD, this one AC minus BD minus AD plus BC. So this is product of two complex numbers, Z1 into Z2, you can remember AC minus BD and AD plus BC. The first component, second component, you can write minus in this, and first, last, second, this second last, you can write this BC. So this is the multiplication of two complex number. Now let us see the example of multiplication of complex number. Let us consider z1 is equals to 1 comma t and z2 is equals to 3 comma 4. So what is z1 into z2? z1 into z2. What is formula? The first means ac minus bd comma ad plus this is BC. So what is the value of A here? 1. You can write 1 into C is 3 minus B is 2 into this D is minus 4 comma A is 1 into D is minus 4 plus B 2 into C is 3. So what we get? 3 ones are 3, minus minus plus, 2 4s are 8, this 4 minus 4 plus 6 means 3 plus 8, 11 minus 4 plus 6, 2. So this is the z1 into z, 11 comma 2. So this is the product of two complex number. This is fifth operations. Next one, division of two complex number. So for the division of two complex number, next let us consider if z1 is equals to a comma b and z2 equal to c comma d, then z1 divided by z2 is again one complex number. So that is defined as a into c plus b into d, b into c minus a into d divided by c. Let us consider one example. Example, z1 is equals to suppose 1 comma 2 and z2 equal to suppose 2 comma 3, or you can write 4 comma 3. So what is z1 divided by z2? You can write first component c square plus d square. What is c here? C is 4 and d is 3. It's 4 square plus 3 square, comma similarly here 4 square plus 3 square. I want here AC. A is 1, C is 4 plus B is 2 and D is 3. Here B is 2 and C is 4 minus A is 1 into D is 3. Here 4 ones are 4 plus 2 3s are 6, divide 4 square 16 plus 9, 16 plus 9. Similarly, 16 plus 9, 4 2s are 8 minus 3 1s are. So what we get here? 10 by 16 plus 9, 25, comma here 8 minus 3, 5 divided by 25, or you can cancel, we get 5 2s are 5 5s are 5 1s are 5 5s are. So your answer is 2 comma 5 and 2 by 5 comma 1 comma 5. So these are the operations of complex number, and these are the concepts of basic concepts of complex number. This is this is exercise 1A complex number. Now first question in the first row, first question is if z1 is equals to 2 comma minus 1, z2 is equals to 6 comma 3. So what is z1 minus z2? Means here difference between z1 and z2 can find. Z1 minus z2 is defined as first component, second first component from the z2 subtract from the first component of z1, means 2 comma minus 1 minus 6 comma 3, means first minus first, second minus second. So what we get here? 2 minus 6 minus 4 and here minus 4. So here z1 minus z2 is the minus 4 comma minus 4. This is the answer. So we need to find next one, second one, z1 into z2. Z1 into z2 is, this is first component. You can write what is the question is if z1 is equals to 3 comma 5, z2 is equals to 2 comma 6, then find the z1 into z2. So you can remember first component into first component means AC minus second component into second component BD minus comma, then first into last CAD plus second into third means BC. You can write this formula and substitute all values. What is AC? A is 3 and C is 2 minus B is 5 and D is 6. A into D means 3 into 6 plus B 5 and C is 2. Is it okay? To simplify, we get the answer 2 3 is 6 minus 5 6 is 30 comma 3 6 is 18 plus 5 2 is 10. So what we get answer? Yes, 6 minus 30 minus 24 and 18 plus 10 28. So this is the product of two complex numbers. Is it okay? Write the additive inverse of the following complex numbers. Next question. So additive inverse is nothing but the negative of a complex numbers. What is that? Additive of complex number is nothing but negative of complex number is defined as, we can write only minus of this, means that is this is z and minus z is additive inverse of this is minus root 3 comma minus 5. So this is the answer. Similarly, first you can do here addition, then find the additive inverse. What is addition here? Minus 6 plus 10 and 5 minus 4. Minus 6 plus 10 is the minus, plus 4. 5 minus 4 is 1. So this is the z, 4 comma 1. And then additive inverse is, inverse is minus z, means minus 4 comma minus 1. So this is the additive inverse of the given question. Same we can do here product. We know that z1 into z2 equal to this first into this first minus second into second, means 2 into minus 4 minus 1 into 6 comma. Now this first into last is 2 into 6 plus 1 into minus 4. So what we get here? 2 4s are 8 minus 6 1s are 6. 2 6 are 12 minus 4 1s are 4. What we get? Yes? Not visible? Minus 8 minus 6 is minus 14. And 12 minus 4 is 8. So this is the additive inverse, this is the z1 into z2. So what is z1 into z2 additive inverse? Additive inverse is nothing but we take the opposite sign of this, minus 14 plus 14 minus plus 8 minus 8. So minus 8, 14 comma minus 8 is the additive inverse of the given question. Is it okay? So this is about the first Roman 3 questions completed. So we can start the second Roman. Okay, if you like the videos, you can share with your friends, and if you are first to this channel, you can subscribe the channel for the more upcoming videos. Exercise 1a, second Roman first question. If z1 is equals to 6 comma 3 and z2 equal to 2 comma minus 1, find z1 divided by z2. So let us consider z1 divided by z2 is a one complex number and z1 is equals to 6 comma 3. So that is a comma b, and z2 equal to 2 comma minus 1. So that is c comma d. Let you can consider. So what is z1 divided by z2? We know that formula. Yes, AC plus BD divided by C square plus D square comma BC minus AD divided by C square plus D square. So substitute all values in this, we get the answer. So what is the value of A? A is 6 into C is 2 plus 3 into minus 1 divided by C is 2 square plus D is minus 1 square, comma. Here B is 3 into c is minus 1 minus a is 6 and d is minus 1. What is the value of c here? 2, sorry. Once again I check these values. C is 2 square plus minus 1 square. Yes, a is 6, c is 2, right, plus b is 3 and d is minus 1, b is 3, c is 2 minus a is 6 and d is minus 1 divided by this. Okay, you can calculate this. We get the answer 6 2s are 12 plus minus minus 3 1s are 3, 2 square 4 plus minus 1 square 1 only. Okay, 3 2s are 6 minus minus plus 6 1s are 6, 2 square 4 plus 1 square 1. Is it okay? Now we get the answer here 12 minus 3. 12 minus 3 is 9. Here 5. 6 6 12. 12 divided by 5. So this is the answer. Z1 divided by Z2 is the 9 by 5 and comma 12 by 5. Okay, next question. Okay, next question. If Z is equals to cos theta comma sin theta, find the Z minus 1 by Z. So first we need to find 1 by Z. 1 by Z is equals to 1 by cos theta plus I sin theta. So we can do here a rationalization of this Z is denominator, multiplying cos theta minus I sin theta. Similarly, denominator cos theta minus I sin theta. So we know that one formula a plus b into a minus b. So numerator into numerator, 1 into this cos theta minus I sin theta divided by here a cos theta means cos square theta a square minus I square and sin square theta. So I square value is 1. So therefore cos square theta minus 1 minus minus plus 1 sin square theta. Here cos theta minus I sin theta. So that nothing but cos square theta plus sin square theta. So that is a 1. So therefore cos theta minus I sin theta divided by 1. So this implies that cos theta minus I sin theta. So what is this 1 by Z value? So you can substitute 1 by Z in this given equation. So what we are going to find? So therefore now we can find Z minus 1 by Z. What is Z? Z is cos theta plus I sin theta minus 1 by Z is cos theta minus I sin theta. So what we get here? Cos theta plus I sin theta minus cos theta minus this minus plus I sin theta. Minus cos theta plus cos theta can cancel. What is remaining? I sin theta plus I sin theta means 2I sin theta. So this is the answer. Z minus 1 by Z is 2I sin theta. Now next question is write the multiplicative inverse of the following complex number. So additive inverse is nothing but Z is the additive inverse of minus Z and minus Z is the additive inverse of Z. So similarly, multiplicative inverse is nothing but, so Z is the multiplicative inverse of 1 by Z and 1 by Z is the multiplicative inverse of Z. So we have given Z and to find the 1 by Z. So we seen in the previous example, suppose Z is equals to A plus IB and 1 by Z is A minus IB, you can remember. Okay, or suppose Z is equals to A comma B, then 1 by Z is A comma minus B. Means A comma minus B is the multiplicative inverse of A comma B. So first example 3 comma 4. So what is the multiplicative inverse? Yes, 3 comma minus 4. So this is 1 by Z and this is Z. What is multiplicative inverse? So let us consider Z is equals to A plus IB and 1 by Z is the multiplicative inverse of z, that is a minus ib. Suppose z is equals to a comma b, and 1 by z is a comma minus b is the multiplicative inverse of z. Similarly, for example, z is equals to 3 comma 4. So, what is the multiplicative inverse of 3 comma 4? 3 comma minus 4 is the multiplicative inverse of 3 comma 4. Similarly, z is equals to sin theta comma cos theta. Sin theta comma minus cos theta is the multiplicative inverse of second one. What is the third one? So, third is the z is equals to 7 comma 24, and what is z? 1 by z. Fourth, similarly, z is equals to minus 2 comma 1. So, what is the multiplicative inverse? 1 by z. So, these two are your homework. So, if we get the answer, you can comment on this video answers of these questions. You can solve and comment in this video comment section. Okay, thank you. If you are like the videos, you can share and subscribe the channel. Okay, thank you.